Okay, this next example, I want to go ahead and connect it to what you learned in chapter 6. So if you recall, one of the ICA problems was given, or maybe in the entrance card or exit, or entrance or exit problem. You were given, so a new car is worth $24,000 and it's depreciating in value, meaning it's losing value, right, every year by $3,000. And hopefully that makes sense, right? I mean, if you buy a new car for $24,000 and 5 years later you want to sell it, you can't sell it for $24,000 because it's used. And I mean, you could sell it for 24,000, but I don't know if how many people will buy it after the miles you've put on it. And again, hopefully that makes sense. So one of the it was an application problem, and I wanted you to translate this to an equation, and we translated it to so we start out with 24, let me get my pen here. So we started out with $24,000, okay, so here's $24,000, right? But every year it loses $3,000, right, per year. So we're subtracting, right, because, I mean, it's losing value, $3,000, right, per year. And we call that per year, right? This is in years, right? X, if you want to call it, uh, some people like to call it T for time, right? In years. But this is an algebraic expression, right? I mean, if X is 1 year, it's going to be 24,000 minus 3,000, right? If X is 2 years, it's 24,000 minus 6,000 and so forth. So I want to connect this to, we're actually going to graph this equation. And again, this is your, all right, again, connecting, this is your algebraic expression, right? It's not an equation, I have no equal sign, but I can make it into an equation by, obviously, right, putting an equal sign. Well, what does all this give me, right? If X is an input, right, 24,000 minus 3,000 X is an output, depending on what X is. So my output is going to be Y, okay? And again, we've been calling Y f of X. I'm just going to call it G of X because you're going to see some problems with G of X. It doesn't matter. I mean, sometimes if we're talking about height, we'll call it H of X, G of X, P of X. Pick your favorite letter. So G of X is going to be equal to this expression. Okay, so this is obviously the equation that, right, I'm giving you, right? There's your equation. And I want you to graph this equation. So let's go ahead and make a table. So here's X. And then, of course, I have my G of X equals, again, 24,000 minus 3,000X. And again, I mean, you can, in this case, let's use positive numbers. In the last example, right, I think it was -2, -1, 0, 1, and 2. Well, I'm not going to use -1 in this case because it doesn't make sense. I mean, in -1 years, well, it's going to be 1 year, 2 years, 3 years, but there is no negative here. We're really just working in quadrant 1. So if X is 1, then I'm really finding G of 1, okay? This is the new function notation, which means if I input 1 for X, what do I get for Y, right? Which is your G of 1. So this is just going to be 24,000 minus, well, I mean, 3,000 times 1, right? Or 24,000 minus 3,000. And if we subtract those, right, we get 21,000. So 21,000. And I'm running out of room here, but I can just scooch over. Okay, so what is my, what's the point, right? What's the ordered pair that I found, right? What's my X comma f of X, or actually in this case, I called it G of X. So let's use G, whoops, let's use g of x, right? Or again, your input, and I think my output was blue in the last example, right? There's your output. So if x is 1, I might as well make it yellow, 1, then what's my, if that's my input, what's my output? What's g of 1? Well, it's definitely 21,000. Okay, so that's 1 point. So now let's maybe find maybe 2 more. Okay, so if x is 2, g of 2, and again, might as well, it doesn't hurt to color code things 1, 1, but now I'm plugging in a 2. Well, this is 24,000. Make this a little bit smaller. Minus 3,000 times 2. Well, that's just 24,000 minus 6,000, right? Because if we double 3,000, we get 6,000. And we get 18,000. So what is my ordered pair, my point? Well, if my input, right, after 2 years, the value of the car is going to be 18,000, which makes sense, right? I mean, it's less than 21,000, and make sure you this makes sense. I mean, if you're getting 25,000, well, after 2 years, which is longer than 1 year, it should decrease in value, shouldn't increase in value. Okay, and maybe after, 3 years, g of course, 3. And again, we're evaluating 24,000 minus 3,000 times 3 is 24,000 minus 9,000. Again, I'm running out of room. So we get, well, we can write it in, I'm running out of room, but that's 15,000. So what is my ordered pair? Well, after 3 years, the value of this car is $15,000. And I want you to understand, right, these quantities, right, whoops, don't cross that out. I meant to use the pointer here. My 1, 2, and 3, right, this represents years, right? And my blue, right, my Y value represents money, okay, the actual value of the car. So again, different quantities, this is years, and of course, I mean, the value of the car depends on what year. I mean, after 1, 2, 3, after 10 years. Okay, so we found 3 points. I'm going to go ahead and graph this. And again, just a quick sketch. So let's see, our scale, well, we know, okay, I technically don't have to, I'm only going to use quadrant 1 because we only have positive numbers. So I'm actually going to erase this. And let's see, let me maybe move this. Okay, so we're only dealing with quadrant 1. So my x-axis, right, that's years. And my y-axis, right, my y-axis, or my g of x, right, represents the value of the car. So we can, maybe this is 1, after 1 year, after 2 years, 3 years, 4 years, and so forth. And let's see, we're in thousands, so maybe we can say 5, 10, 15, maybe 20,000, right? So this is 5, 10, 15, right? This is K, right? Thousands, K, 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 and K. And then we just plot our points. So 1 comma 21,000, so after 1 year, the car's value, right, started at 24,000 is, well, this is 20, right? So we're just kind of approximating. So this is 1 comma 21,000. So 1 comma 21,000. And then we have 2 comma 18,000. Well, here's 15, right? So 18 somewhere in here after 2 years. So maybe 2 comma 18,000. And then finally after 3 years, 15,000 is right there. So 3 comma 15,000. And if we connect, right, these points, you actually get a straight line. And that is the equation, right? And hopefully, or the graph of this equation, hopefully it makes sense. This line is decreasing, right? After, right, the more years that go by, right, the lower the the lower the value of the car gets. And I think, let's see, one of the problems, I think in your, I want to say your entrance problem, I think we asked after how many years will the car's value be $9,000. Well, I mean, you can kind of see, well, if this is, right, this is $10,000. So $9,000, I mean, by reading the graph, you can kind of figure out how long it's gonna take. And I think it was like 5 years. So again, connecting chapter 7 to chapter 6.